Let me share my screen. Guys, how are you? When you join, turn off your camera, okay, to reduce the data. The things we saw yesterday, I can't find anything. Just create a new sheet. Today is the 10th July. Okay, guys, you said there's a question in. Is it this question?
611.
Is it this one? A body of mass 10 kilograms. Is it that?
So let me zoom and check. They said three forces was acting on it. So the page.
Is it this question?
I'm zooming. So please no, not this one.
Is it the next one?
Page 611.
611.
Yes.
This one. This one.
11. So please go down. It's here. Yeah, this example.
Okay.
This one. Example 6, not the 7, the 6.
Okay, this one.
Yeah.
Okay,
I had the drawing and everything, but it was wrong.
Okay, it says a uniform plank XY of mass 40 kilogram and length 30 meters rests horizontally on two supports P and Q, where PX is 8 meters and QX is 18 meters. Objects of mass 10 kilogram and 5 kilogram are hanged at M and N. Are you listening?
Yes.
Are hanged at M and N respectively, where M2X is 10 meters and NY is what? 6 meters. If the system remains in equilibrium under the action of these forces, calculate the pressure exerted on P and Q. Okay. So let's solve it. You solved it already, eh?
Say, I was solving it. I didn't do the diagram, but the answers were wrong.
Okay. And let's all try again too.
Okay.
Give me a moment. I'm sharing the link on it. What's up? So let's start. Let me draw the diagram. Good morning.
Morning, Lord.
Which I say.
I heard one answer. Oh, yeah, but sister knew.
Nice. So let's continue the question. So this is a uniform plank XY. So back and away for table. Oh, my writing pad is maybe behind. So XY. XY. So this is our uniform plank, right? So it has the length here 40 and has a mass of, so let me put the XY here, X and Y. It has a mass of 40 kilograms. So in the middle, because it's uniform, in the middle will become the what? The weight. Right. The weight is in the middle. They should have given you the gravity. Let me go and check in Aquila. They should have given you the gravity, the force of gravity. So if it's not there, let's use 10 meters per second as the force of gravity. So the weight becomes 40 times 10, which is 400 newtons, right? And length 30 meters. So from here to here. Sure. So let me just duplicate this one. So drawing of the diagram is very effective. Everybody should learn how to draw the diagram. Secant line. Right, very good. And 30 meters. So everything here is 30. If you divide it into 2, you're going to get 15. Oh, sorry, 15. So 15 and 15. Right. Now, rest on two supports P and Q, where P to X is 8 meters. So if this is 15, if you divide 15 into 2, you get 7.5. So 8 meters will be around here. Here. Then the support of P, 80 meters. Wow. 80 meters means it's going to be around here. It's going to be more than the distance. My tympano is so how much? It's going to be more than the, what do we call it? The midpoint. So let me move this one a little. So let me put the 8 meters around here. 8 meters around here. Then if this is 80 meters, it means it's more than. So here will be the Q. And the P will be around somewhere here. I beg to differ. I don't know if it's it's a wrong variable here, because it will make the distance balance. It will make all the pivots on one side. It will make the question balance. It will make the beam balance.
Hey,
Yes.
say,
Yes.
say, but man, I moved the Q like it crossed the midpoint. You see, from X to the midpoint is 15.
Okay. Let me read the question again. Let me read the question well, because this story problems. If you don't read the question well, it go mafia you. So this P to X is 8 meters. P to X is 8 meters. Okay, I'm now getting it. P to X is 8 meters. So if here 7.5, it will be around here. Then Q to X is 80 meters. So it means, okay, I get it now. 15, 16, 17, 18, it will be around here. Because if here is 15, we can divide the 15 to 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My internet is disconnected. Okay. Then Q to X is what? 80 meters. So 15 plus what will give you 80 plus 3. Right. So that 15 plus 3 will give you 18. Now 15 minus 3 will give you what? 15 minus 3 will give you 12. So from here to here is 12. Okay, so now we have all our distances. Benjamin, I hope you get it.
Yes, please.
Now it says that objects of mass is 10 kilograms and 5 kilograms are hung at positions M and N, such that M is 10 meters from X. So M to X 10 meters. So this is 15. Let me divide it into 5. The 15 divided by 7.5. This is 8 meters. So 10 meters will be around here. Let me use a red pen. 10 meters will be around here. 8 and 10. 7.5, 8 and 10. Let me put 10 meters around here. So this is the weight of M. Right. From here to here is 10 meters. And what else? NY 6 meters. NY. So 6 meters from here. This is 6 meters. So if the system remains in equilibrium under the forces of three, under the action of these three forces, calculate the pressure exerted on P and Q. Calculate the pressure exerted on P and Q. That's what I may not understand when it's here.
Say,
Yes.
say, but he gave the masses for M and N.
Yes, 10 kilograms and 5 kilograms. Okay, so this becomes 100 newtons, and here becomes 15 newtons. And also, they didn't talk about reactions. And let's discuss. It says if the system remains in equilibrium under this function, under the action of these three forces, calculate the pressure exerted on P and Q. So, what do you think?
So the pressure is equal to force over area.
No, I'm not sure that's the pressure that I'm talking about. This question, I remember I've solved it before. It's been a while, but I remember I've solved it before. So let's discuss.
So if you don't,
I'm tempted to think it is the reactions.
that's what I did, but the answers were wrong. Yes. I had R1 to be 155, which is the P, but it was wrong.
So let me try doing it to AI. I'll show you this one. This one, we're all learning. So let me see. So you see, the only aspect is the pressure, right?
Yes, the pressure.
So let's see. Let's use the listing, the reactions at this place, and use it as a pressure, because that's obviously what will come in mind, right? I'm just playing the devil's advocate. So let me see. Reaction 1. I don't know why that thing is cleaning. Reaction 2. So sum of upward forces. Sum of upward forces. Cause sum of downward forces. So R1 plus R2 cause 100 newtons plus 400 plus 50. Did you do it this way?
Say,
I said you did it this way.
yes, please. So, but they are saying if the system remains in equilibrium under the action of three forces,
you have a point though. You have a point. I mean, let's just play the devil's advocate as if you don't know that part, right?
Okay.
So this gives us 550, right?
Yes.
Then taking moments about one of the pivots. Let's say maybe taking moments about P. So if you are using P as the pivot and Q is eliminated, let me come down. Let's look at the sum of clockwise movements. let's figure the sum of clockwise moments around P. The clockwise moments are 100 newtons, the weight, and N, right? So now the distance from P to this place. Let me diagram. Now give me a repeated diagram. The best side there. So. Taking moment about P. So the clockwise moment, sum of clock cause sum of anti-clock. So from P to the first clockwise, because this first will be clockwise, this one will be clockwise, this one will be clockwise, this one will be clockwise. Right, they're moving in the clock direction. So from P to the first force, this was 100 newtons. What's the distance over there? Initially from here to here is 7, right? From over here you have 8. 8 plus 2 gives you 10. So here will be 2. From here to here will be 2. You get it? The 8 to the from X to M. You see we have 10 here and we have X to P is 8. So you have to add 2 to get the what? X to M. Are you okay? Plus another movement from P to the weight of 400 newtons. So from P to that one is 7. Right? Plus another clockwise direction, which is from P to what? To N, which is 15 newtons. What's the distance from P to N? If here is 12 and here is 3, and YN is 6 meters. So if you subtract 6 from the 15, it means from the midpoint up to here is 9. 9. So now 9 plus this 2 will give you 11. And 9 plus 7. 9 plus 7 from the midpoint to P. So 9, 10, 11, 12, 13, 14, 15, 16, 16. That will give you the anti-clockwise moment from the P to the upward R2. Right. Because this one is an anti-clockwise moment.
Yes.
To move, it moves upwards, so it will move the whole beam in an anti-clockwise direction. The ones which are moving downwards will move on the whole beam in a clockwise direction. So now let's do this one. Multiply this and this. The first times perpendicular distance. First times perpendicular distance for this one. So this is with you.
So the R2, what about the distance?
Come again.
The distance.
Yes, the distance is 16. It's 9, 7 plus 9. From P to the midpoint is 7. Plus from 9 to distance, so 16. Or is it not 16?
So it's not 16. I think it's
R1,
10.
okay, R1 is 7 plus 3, 10. From 7 to 3. It's 10. You get it?
Yes. Yes.
So 7 times 400 plus 16 by 50. Hey, the others, do you understand what we are doing? It shouldn't be one person something, no? Please, are we on point? Hello.
Oh, yes, please.
Okay. Let's check the P and the 400. The distance is 7, okay. Okay, so this becomes 200 plus 4, 7, 28 plus 16 by 5. $800 cost 10R. So after this are we okay?
Yes, sir.
Okay. So now let's solve it. This gives us let me counter this one. By 7, 800. So 800 plus 200 plus 800.
Hey, you worry me.
3,800. Somebody's worrying you, eh? Cancel this and this. 380. Let's check if R2 is 380. Yes, R2 is 380. So the one exited on Q is 380. Please, do you understand? Let me see now we've solved it.
Hey, sir, but I didn't get that one.
Oh, that's what even the answers are in the question. Couldn't you see it?
Yeah, I saw it, but I didn't get that. So you see me, I took moments about Q.
If you take moment about Q, it should give you the same answer. This one over here, 380 newtons is the value of R2. So you just go and put this one into the equation 1. Come and put it inside this equation. Come and put it here.
Actually, 550 minus 380.
So R1 is 550 minus 380.
Yeah, you get 170.
So the pressure exerted at P is 170 newtons and Q at Q is 380 newtons. Are you okay now?
Yes, please.
Okay. Please, the rest of the squad on the link. Please, are we okay? Do we understand? Famous and the rest. Nora, what you say? Oh, you didn't join earlier. So the only thing here is the pressure. It's a pressure word normally you say. If you don't take it to confuse you. But just play the devil's advocate as if you've not even heard the word pressure there and you're just balancing stuffs. Okay.
Okay.
Okay, let's
Just like I've seen my mistake. Hey, my mistake.
I'm sure you made a mistake somewhere. Yes, mistake somewhere.
Yes, I've gotten the answer. I've seen my mistake.
Okay. It's good you've also solved such a question. Okay, can we do this one? The diagram shows a uniform rod PQ mass 10 kilograms, which is held in equilibrium by two strings which are attached to P and Q. At the end of P, to the ends P and Q of the rod, the strings are inclined to vertical. The strings are inclined to the vertical as shown below. To calculate the tensions in the string. So let's see if we can do something like this. Mahram sir. This is easy. So let's draw the. Okay, they've drawn the diagram for us already. So no ED. Let's just complete the diagram. Right now, the weight is 100 newtons. Let's just assume that we know the weight, the gravity as 10. So 100 newtons. You should have given us the gravity, but let's see. Two strings. So this is string 1. Tension in the string C1. And tension in this one C2. Now the strings are inclined to the vertical as shown below. Calculate the tensions in the string. So how do you calculate the tensions in the string? Yes, let's discuss. Hello? Hey, are you there? Mungasa. Hey, are you guys online? Nora and his friends, are you online?
Yes, please.
So let's discuss the question. This is more like movements with Lami's theorem altogether, or strings altogether. So let's see. How can we resolve this question? How can we find the tensions in the string? This question is more of a this thing. It's more of a movement. Lami's theorem. Tensions in string problem. So, what do you think is the best approach to use? Sorry, I've muted myself. I unmuted myself.
Yes.
Yeah.
Please, I don't understand the question.
Yes, it says calculate. This is a diagram they've given to you, right? The uniform beam of mass. They didn't even give you the length of the beam.
Then we should calculate for the tensions in the string.
Yes.
And
it's also
we should try. Should we try?
Come again.
Should we try?
That's what I'm saying. We are all discussing of how to solve such a question. So such a question, this question is more of a string problem, right? One thing we know is that sum of upward forces equals sum of downward forces, right? I hope you get it.
Yes.
It's more of a moment problem and also a string problem. So I told you that when these forces, see, when we started doing moments, we said something like this: it's force times perpendicular distance. But sometimes the force can be inclined at an angle, right? So you have to resolve the perpendicular one and use that one, right? So in this problem, this is the object we are talking about. See everything here as a very big object, right? And the weight is downwards, right? This is something like this. And this is the object, and it is what, 40 degrees to the 50 and 40 degrees to the vertical. So if it's 50 here, 50 and 40 here, right, it's going to be 50 here and 40 here. So basically that's what we are talking about. But this time around, it's not just a straight line, or it's not just a straight object or a round object. It's an extension.
See, I'm not getting your drawing.
I'm saying that, see this line PQ as a very big object, just like how we've been doing it in Lami's theorem.
Yes.
But this time around, you're going to resolve these forces as well, upward forces and downward forces. So this T, you're going to resolve this T as a what?
A downward force.
As an upward force.
The T1.
You're looking for the perpendicular force to the object. Right? You're looking for their perpendiculars to the object. But these angles here are not perpendicular. We don't even know the total angle here. But what we know is that here is perpendicular. Here is also perpendicular. But we want the force that is perpendicular to this object. Right? Even if we extend this one. Even if we extend this one. We don't know we know here is 90. But this line is not parallel to this line, so here cannot be 90. And this line is not parallel to this line. Unless maybe we extend it this way. And this way. That's where we can get 90 here. And this becomes like a hypotenuse, and this becomes T1. Because it's a force, it runs through the same idea.
Oh, okay.
The magnitude runs through T2. Right? And they didn't even give us the distance of PQ. For the diagram, they didn't give us the distance of PQ. So let's draw it properly. So these are some of the questions that will come in the exams. Like, basically, this after they do exams, they won't see a crown either. They So let me solve it. Let's solve it too. These are our weights, vertically downwards. I'm just going to draw weight at 10 times. Right.
Yes.
Now when we extend this diagram, According to the diagram, when you extend it, they don't meet at that point. So, oh my, this is wrong. My perpendicular is wrong. Unless maybe I draw another line parallel to this, like triangular forces. They are not meeting at 90. So according to the book, they drew diagrams meeting at 90 to the vertical, or to the 100 newtons, right? And they resolved it with vector approach. So let's see the way forward. Highlight here the way I'm just trying to find a way around this one so that we can solve it. Because when you're using this technique, these forces don't meet at 90. The way the book has drawn it, they meet at 90, but when I extend it, they are not meeting at 90, and I don't want to believe what they've done. It's like that. Let's see if there's a way around it. For me, I was just thinking that if we can resolve this force, now this line now has been inclined this way. You can pretend the line is straight like this. Let me do it this way. 50. And here's 45. These are the forces. So you see this one. Okay. I mean, screenshots rather. It's like a ladder problem. A movement in ladder problem. You see. Newtons. Something like this, you know. Then we've rotated it around so that this becomes straight.
Yeah, but when it becomes straight, the weight is not perpendicular.
So you have to resolve them perpendicularly, like this. You understand what I'm saying?
Yes.
Resolve them perpendicularly.
That means you are going to get two weights.
No, you're not going to get two weights. It's just one. That force that has been resolved perpendicularly.
So you clean one.
You clean one. You are just resolving it in an angle. Let me use a straight line. I'm just using it. I want to use another way, apart from the way the book used it. You understand?
Oh, yes, sir.
The book's way of doing it, I'm not getting it. I have to. I want to know the reason why they did it that way. Because technically when I join those two lines, it doesn't create an angle of 90 degrees with the 100 newtons. to choose black. Or let me choose blue. Should I use red rather?
Say again.
So now this force and the perpendicular of this one. So this 50 degrees here. How can I resolve it so that it becomes perpendicular to what? Oh, I don't know. This diagram. This one, see it like a problem like this, like a point here P, right? And they've given you an angle like this, 50 degrees to something here. See, something like this, and a higher 50 degrees, and at the ends too we have 45 degrees here. So you see, it is not to the friends. There are no perpendicular lines there. This line is not perpendicular. These angles are not perpendicular. But at least we have this one which is perpendicular. You know that moment we have to use what? Force times perpendicular distance. Right. So now we have these forces which are at an angles. Right. They are certain angles, but we don't know unless maybe use. Now this is a straight line. So if here's 180, we don't even know this part. But we know that this line is parallel to this line. It's a trapezium. Two sides parallel. If I join this line to this line, will here be 45? That's what I'm thinking. If I duplicate this part, I want to use unorthodox method to get the answer correct. Something like this. Let's say any how and she said I mean look small. I don't know if I bring this line, this is this line. That means the angle there is 45. But there's another angle behind the 45. Are you seeing it? There's another angle here. There's another angle here. Line, but I want to just a straight line. Please join at this time. Yes, so if he is 45, it's likely this angle to, because now, but this line is not perpendicular to this line. This angle here is not 90. Angle to this line is not 90. Yeah, it's not 90. So even if he is 45, you have to know the angle. Can we draw some parallels so that we can draw some Z angles? Z angles. This and this are parallel. So we don't know the angle here. Let's say here is K. Here is K. Here's 45. And create an angle of 90 degrees here. If I extend the straight line, problem. They always use vector approach. So still you have to use vector approach to convert this T1 and T2. You read from the north and come here. So in this case, vector approach is the only approach you can use. You read from the north to the 45 degrees and you get the magnitude of those forces. You also read from vector approach from the north to this line. Then after that, these forces are in equilibrium. Even if you resolve them, you add all of them to what? 0, because they're at rest. Hello, please, do you get what I'm saying? Hello.
Yeah.
So we are trying not to use the vector approach, but that's the last option left. So that's why I always say that master all the techniques. Let me delete this ones. So now we can't use any other option apart from the. Okay, we can use any other option, but for now the easiest one is the vector approach. So let's see the vector approach. This one acts vertically downwards. My diagram we're drawing is straight. Now, this is T1, T2. T1, T2. Now, if these forces are holding the thing in equilibrium, it means that when you add all of them, you have to get what? T1 plus T2 plus your weight should give you 0. This weight is 100 newtons. Right, let's use this principle alone, right, because of the word equilibrium. So let's add all the forces over there and make sure it's equilibrium. Now resolve this one from the north. Read the angle from here to here. Over here from the north, read it to 45 degrees and resolve them. So in this case, T1 sine, we don't know the angle here. If we resolve here, we don't know the angle here. Okay, we know here is 90, right? If we use cardinal points, we know here is 90, so here we're going to be 40. So 270 plus 40 will give you what? 27, 28 is like 31. So 31, the fourth here, 50. So everything here. Please, you understand? So T1 sine 27, 28 is like 31. Sine 310. T1 cos 310. That becomes the first force. Then the second force becomes what? That broken line and 45 degrees. So if you're reading from the north, it's T2. So T2 sine 45. T2 cos 45. Plus the weight. The weight is 180. So The weight is 100 sine 180. 100 cos 180. And let's add all of them. We get two simultaneous equations. So let's resolve them. Give me the solutions. Calculator. Sine 310. What will be the answer?
Negative 0.766.
Make sure your calculator is in this thing. 0.766. Okay. Negative 0.766. T1. And the other part cos 310.
0.64278.
0.64. 278. 228 T1 plus sine 45 root 2 over 2. That give me decimal. Sine 45.
0.707.
707 T1. Sorry, T2. Then cos 45. It's the same thing.
Yes.
So 0.707 T2. Now sine 180 is 0.
Yes.
So here is 0. Because 180 is negative 1, so negative 100.
Yes.
Let me just cross check. Yes. Because the 0 vector 0 0. Now we get two simultaneous equations, then we solve them simultaneously. So negative 0.766 T1. Let's move it to the other side rather.
Yes.
So that becomes positive. So T2 0.707 cos 0.766 T1. And we substitution T2 equals 0.766 0.707 T1. Right. This equation 1, this equation 2. So enter 2. Put T2 equals 0.7. Let's simplify this one. The way I don't like this math,
766.
It's 1.083. So 1.083 T1 into equation 2. So if we see T2, that's what you write. So 0.6428 T1 plus 0.707 T2 equals 100, because we move the 100 to the other side. It becomes 0.6428 T1 plus 0.707. Charlie, we shouldn't even solve it because the 0.7 is over here. It's over here. so that they will just cancel out. Do you understand what I'm saying? Let's put it this side directly. I want to group them together.
Yeah, but the T2, the answer is 1.0834.
No. It's this. I wanted to cancel out this thing.
Oh, okay.
So I want to leave it like that.
So I see when you use elimination, it's very easy.
It's true.
Yes. There's 070.
No, cancel each other. Let's use the elimination radar.
Yes. Nice one, good.
Machine has started saying Jimmy. Let's use elimination radar. We find out. The way I like elimination, and me, I'm beating about the bush like that. How do I delete these things? Machine start the fufu. So let's use elimination. Equation 1 minus 2. So this minus this will be the answer. The minus is 0. Everything is in brackets.
And use a calculator to block the.
So negative 0.766 minus 0.6448. All four is something. Negative 1.407. Equals 100. Because this one needs to cancel. The 100 will go to the other side. And because we're subtracting everything here, it will become, the 100 will be positive here, but when it goes to the other side, negative. So this 100 will cancel this 100. Then T1 will be 100 over 1.4088. Do you understand?
So, but the negative is also affecting the 100.
Yes, when it affects the 100 will cross the equal sign. It's going to give you another what's negative 100.
Yes, but it's like you cancel the negative 100.
So negative and negative will cancel, because over here when I add this and this, I'm getting negative. Over here when I add this and this, they subtract each other. And when I multiply the negative by this 100, it's going to be positive. Then in the long run, I'll move the positive to the other side of the equation, giving you a negative. Yes.
So when the negative 100 goes to the next side of the equal sign, it is going to be positive.
No. Okay, let me do it step by step.
Like a 0 minus 100, so it will be 0 plus 100. And remove to the other side.
So it will be negative 100.
Wait, let me do it. Let me do it step by step. Let's do step by step. This one gives you what? Plus what? 0 plus 100 equals 0. Are you okay now? Are you okay now?
There's no plus 100, it's minus 100.
No, the minus here is multiplying this negative 100.
It's minus
plus 100.
minus.
Okay, sure.
Yeah. So now, when you move this one to the other side, it's going to be 100 equals 1.408831. Right?
Exactly. Yes.
Divide this by 100, what will you get?
0.014288.
Hey, okay. 100 over 1.4088. 70.9.
Yeah, 70.98.
But that's not what the book had. The book had 64.3.
Hey. So let's go back to the diagram.
We are correct. The book made a mistake in the diagram. You see, the diagram, instead of using 45, they use 40 right here.
Okay.
So they made a mistake, sign 40, because 40. So you are right, it should be 45. So then after that, go and put inside one of the equations. So put it in equation 1. .98. It becomes negative 0.766 T1 plus 0.707 T2 equals 0. So let's put the T1 there. Negative 0.766 70.98 plus 0.707 0. When you multiply this and this, what are you getting?
Negative 54.3706.
Negative 0.766 times 70.98. Negative 54.37.
068.
37. Let's move it across the equal sign. Charlie, my trust are my brain. Then you'll be positive.
Okay.
Equals equals everything over 0.707 T2. I hope you understand. You move the answer here to the
Yes,
other
sir.
side, then divide both sides by 0.707. So answer over 0.707.
76.033.
Hey, are we getting negative? And then I'm punching it here.
You got 76.
76.911. Newton equals T2.
Hey, 2 decimal please.
It's okay. So I think this is the ideal solution. Are we okay?
Yes, please.
Okay.
Yeah, I think it's 5:30. Let's go and bath and go to school. So, you see, this question is not, it's an moment, or it's an, the most important thing is that solve the problem, whether it's an moment or it's an tension. Because the question doesn't clearly state that it's a moment or something. But you have to use your mind to resolve it. The equilibrium effect, when all the forces come together, it is equal to 0. That's what helped us. Otherwise, we will be beating about the bush, trying to use Lamb's theorem or moments. There are a lot of moments question in the past question. So if you have some, try and solve it. Try your hands on it. Okay. Charlie, it's good learning with you guys. So go ahead and tomorrow morning to continue.
Okay.
I'll send a PDF in the page there.
Okay, thank you.
Okay, you're welcome. Right. So we meet again. Say calculus.